Sometimes simultaneous equations go beyond linear equations. There are problems you come in contact with and you notice that the problems contain not just a linear equation but also a quadratic equation, as you see right here on screen. We want to find the values of the unknown variables in the given equations. The first one is p squared minus 4q squared is equal to 9. And the second one is p plus 2q is equal to 1. Notice that the second equation we have here is a linear equation, but the first one is not linear. It is a quadratic problem. This is the kind of problem called simultaneous equation involving one linear and one quadratic. Welcome back to Whiteboard Math Party. Let's swing into action. To do this, first of all, let's rewrite the equations and put them where they belong. So first thing first, I have p squared minus 4q squared is equal to 9. This I am going to refer to as my equation 1. And the second one, which is p add 2q is equal to 1. This is my second equation, which is equation II or equation 2. Now that we have reached this level, one method that will deliver us here is the substitution method, since trying to eliminate will take us a very long way. So the substitution method always makes this kind of problems easier to solve. Alright, let's do that. Take a look at equation 2, which I'm going to take from. So I'll say from equation 2, that is from II, we know already that p plus 2q is equal to 1. What this implies is that p can actually be equal to 1 minus 2q. I have just ended up creating yet another equation, which I'm going to call equation 3, and this is for p. Since I've done this successfully, we are going to now put back. We took from equation 2, so we have to put back in equation 1. Okay, so from 2 into 1. All right, remember that. I will use the word put. Okay, put p equal to 1 minus 2q into equation 1. We are putting back into equation 1 or equation I because we've collected from equation 2. Okay, so if I do that, the first thing I already know is that in equation 1 we have p squared minus 4q squared is equal to 9. This is what we know. So I'm going to be substituting the value of p, which is 1 minus 2q, into this equation 1. But notice something. Do you see difference of 2 square here? I can choose to simplify it first before solving, yeah? Maybe to make my work easier. So let me just do a little simplification before substituting the value of p, which is 1 minus 2q, into equation 1. I'm doing it right away. This p squared minus 4q squared can actually be rewritten as p squared minus 2q all squared. Remember, everything is still equal to 9. So if I simplify this using difference of 2 squared, this is going to be p minus 2q in one bracket, open another bracket, p plus 2q in yet another bracket, all is equal to 9. Now we can substitute our value for p, or our equation for p, into this expression with all being equal to 9. So let's do that. With p being 1 minus 2q, this bracket will change to the place of p takes 1 minus 2q. Now minus the 2q in the bracket, close the bracket, open a new one, p again. Remember, p is 1 minus 2q, so I'll bring it again, 1 minus 2q. This time in the bracket we have plus 2q, close the bracket, all is equal to 9. Alright, let's simplify. 1 minus 2q minus 2q will be the same thing as 1 minus 4q in one bracket. Open the next. 1 minus 2q plus 2q leaves us with just 1. So everything is equal to 9. Now that we have reached here, it's time to open up the brackets. Remember, when you multiply anything by the number 1, it remains the same thing. So 1 minus 4q multiplied by 1 remains 1 minus 4q, which I'm just going to transport to this side of my paper. 1 minus 4q remains what it was. But on the right hand side, we are told that it is equal to 9. So I'll just write equal to 9. Have you seen that the case has changed to a linear problem? So this will be easier to solve. Now I'm going to collect like terms, leaving negative 4q on the left hand side. On the right hand side, I'll be having 9 minus 1. Negative 4q still remains on the left hand side, while on the right, 9 minus 1 gives us 8. It is time to find the actual value for q. And the only way to do that is to remove negative 4. To remove negative 4, you divide both sides of the equation by the coefficient of q, which is by negative 4. So I'm dividing by negative 4. Now on the left hand side, negative 4 on the numerator cancels out the negative 4 on the denominator, leaving us with just q. But on the right hand side, when you divide 8 by negative 4, you are left with negative 2. So this is it for q. The value of q in this equation we are given from the beginning is negative 2. But what about p? Remember that we mentioned earlier when we derived the value of p being 1 minus 2q. So I'm going to bring it back into this calculation we are doing right here. So I'll just say recall that p, which you see here, is equal to 1 minus 2q. That we found in equation 3. Don't forget that. So what it means now is I'm going to substitute the value of q into this. Since q is already negative 2, this will not remain the same. So what it means now is that p now will become 1 minus 2. Instead of writing q, I will use the actual value of q in place of it, which is negative 2. So let's simplify this. P now becomes 1. Negative 2 multiplies negative 2 will give us positive 4. So P will become 1 plus 4, which is of course equal to 5. So what this means is that while the value of P is 5, the value of Q is negative 2. Solution set. Let's represent it. Our solution set now for P, Q now becomes 5, negative 2. This is what it is. We have ended up using our substitution skill of solving simultaneous problems to solve one linear, one quadratic, and we've ended up with this answer. I hope you enjoyed this lesson for today, and I hope it's easy enough. Thanks a lot for watching. See you soon.